Hello and welcome to the OKSI Navy STP Tech Talk presentation. The topic of this Tech Talk is the Super Resolution for Mid-Wave Infrared Imagery Enhancement, or SUPREME. OKSI has developed this technology under the NAVC topic Improved Infrared Imaging with Variable Resolution achieved by a post-processing, which is sponsored by PEO-IWS. Before we start, please allow me to give you a brief introduction to OKSI. OKSI was founded in 1991 with a focus on building hyperspectral imagers. Over the past 30 years, OKSI has expanded our scope to encompass remote sensing, autonomy, vision-based navigation and guidance, and edge computing while being repeatedly recognized for excellence in research and development and in commercialization. This includes receiving the Army Quality Award for technology developed under an SBIR program, as well as earning the Tibbets Awards that recognizes commercialization success based on SBIR technology. OKSI has a broad cross-section of government customers including the Missile Defense Agency, the Navy, Air Force, Army, Intelligence Community, NASA, Department of Energy, and NOAA, as well as a broad range of commercial customers. We take concepts and develop them all the way through prototypes that prove their effectiveness and then into products that deliver value in the real world. Our expertise at OKSI is in multidisciplinary systems engineering with an emphasis on EO/IR remote sensing, machine vision, and artificial intelligence. OKSI has the capability to build complete systems or to contribute subsystems to larger projects. This includes modeling and simulation of the phenomenology to be observed, designing and building hardware and software to perform those observations, implementing algorithms to extract useful information from the raw data, and implementing real-time processing. Our projects cover the full EO/IR spectrum from UV through long-wave IR, and we have built multispectral and hyperspectral imaging spectrometers and situational awareness sensors. In recent years, our portfolio has expanded to include autonomous systems, deep learning and machine vision, guidance and targeting packages for munitions, and mid-wave IR lasers and absorption spectroscopy instruments. I'll turn now to the Navy challenge that motivated SUPREME. The Navy typically uses mid-wave IR imagery for two distinct purposes. The first is weapon system functions, things like target recognition, target identification, and aim point selection. These applications require high spatial resolution. The other type of application is situational awareness, which inherently requires a very wide field of view, such as 360 degrees or even a full hemisphere. These two different types of applications drive the optical design of an imaging system in opposite directions. Therefore, if you wanted to have a single conventional system that fulfilled both functions, it would require an extremely large focal plane array, which would be very expensive. Another option would be to have two separate mid-wave IR imaging systems, one for each type of application. This is the approach taken by the SPEAR system currently under development, which couples a wide field of view situational awareness system with steerable high-resolution, narrow field of view sensors. However, cost and available deck real estate limit the practical number of narrow field of view sensors that one platform can host, limiting the number of sectors or potential threats that can be imaged simultaneously. So, with existing technology, the capacity to fulfill both weapon system and situational awareness functions simultaneously is limited, and a need exists to increase this capacity without simply adding additional sensors. Therefore, OKSI has developed the Super Resolution for Mid-Wave IR Imagery Enhancement, or SUPREME technology. The solution is to enable the situational awareness mid-wave IR system to also perform weapons system functions using super resolution, thereby reducing the burden on the limited number of narrow field of view systems, increasing the information available to the warfighter, and extending the battle space. With a mid-wave IR system designed such that the raw imagery is suitable for situational awareness, spatial enhancement processing can be applied to a selected region of interest to produce imagery with sufficient resolution to support weapon system functions. This requires a higher level of spatial enhancement than previously available before SUPREME, particularly because most super-resolution solutions were developed for use with visible imagery that has very different characteristics than mid-wave IR. Therefore, OKSI has undertaken to develop, implement, and demonstrate a new super resolution method specifically designed for midwave IR imagery and producing high levels of enhancement. In addition, this new method enables the super resolution parameters to be tuned for individual imaging systems by considering system-specific attributes. This means that the same software can be used with multiple deployed systems. While the motivation here is to enhance situational awareness imagery, making it suitable for weapons system functions, the method can also be applied to refine imagery from dedicated high-resolution systems to produce even higher quality imagery. In Phase 1 and Phase 2 of this effort, OKSI partnered with computer vision experts at Northwestern University to develop Supreme. The method operates by first locating and then enhancing edges within the image while maintaining the smoothness of the image away from the edges. Each edge is sharpened and enhanced by imposing an explicit mathematical representation or prior for midwave IR edges that is balanced or regularized against fidelity to the raw imagery. This formulation directly incorporates camera parameters such as the F number and the undersampling ratio, and therefore can be tuned for individual imaging systems. In the current CRP phase, Supreme has been demonstrated to provide real-time variable resolution capability in regions of interest that provide significant benefit for automatic target detection, recognition, and tracking applications. Development and integration of Supreme is on track to be ready for transition to the Shipborne Passive EO/IR, or SPEAR program. In previous milestones, the Supreme method has been applied to representative pre-recorded imagery and in near real-time in live demonstrations. Most recently, Supreme has been demonstrated in real-time integrated into a pipeline for automatic target detection, tracking, and recognition. Within the next year, Supreme will be integrated into a fully representative pipeline for real-time operations and will achieve TRL-7. Supreme offers many potential benefits for integration into midwave IR systems. While Supreme is a software method, the primary benefit is its impact on hardware by enabling the use of midwave IR sensors to perform both weapons system and situational awareness functions. Supreme has an advantage for this application over other super resolution solutions because it was specifically designed for midwave IR. In addition to integration into new midwave IR systems like SPEAR, there is also a market for Supreme to be used to upgrade existing systems without requiring any changes to imaging hardware. In terms of SWaP-C, Supreme benefits every point. By enabling the use of smaller focal plane arrays, Supreme can reduce size, weight, power, and cost. This may also have a multiplier effect, as smaller, lighter sensors can use lower SWaP-C mounts and turrets. The current transition target for Supreme is integration into the core image processing capabilities of SPEAR. Supreme can also transition to and benefit other Navy programs. Potential benefits exist in any application where midwave IR images are planned or are currently being used both on Navy vessels and aircraft, as well as in other DoD branches. For new applications, Supreme can enable lower SWaP-C sensors, and for existing applications, Supreme can provide upgraded capability without requiring hardware changes. Some specific programs where OKSI believes Supreme would improve performance are periscope-mounted sensors, such as the Saffron Series 30, small SWaP-C sensors for UAS, like the FLIR Neutrino, and airborne systems, including the NGC Lightning Pod. Outside of the DoD, Supreme again potentially provides benefit in any application where midwave IR images are used. Security applications in particular are transition targets both for new programs or products and for upgrades. The path forward on all of these potential transition opportunities is through introductions and socialization, presenting the benefits of Supreme to decision makers. This can help to create a pull on the warfighter side for the capabilities offered by Supreme to be incorporated into programs. At the same time, OKSI is looking to partner with one or more primes to push Supreme out to the warfighters, like with SPEAR, through other programs. Supreme is not a standalone product, but it can enhance the capabilities of the tools provided to the warfighters. Thank you for attending this presentation about Supreme Super Resolution for Mid-Wave IR Image Enhancement. If you have questions, would like additional information, or would like to start a conversation, please contact us by phone or email using the information listed here. With our broad experience and capabilities, we are always happy to discuss requirements and potential solutions that OKSI could apply to help you achieve success in your programs.